Hello world. Today I'll be doing my IWSP final project demonstration where I'll be using the IoT cloud data to control the Turtlebot tree. So for my project, I have already divided it into three parts. The first part I'll be going through is the IoT setup. The second part would be the ROS setup. And the last part would be combining both setups into one. So for the IoT setup, it comprises of the Adafruit IoT platform, and I'll be using the Tony IDE to control the microcontroller, which is the Raspberry Pi Pico W. So first things first, what I'll be doing is demonstrating how to set up the Adafruit IoT platform. So on the left, you can see this is the final dashboard that I have. And to achieve this is quite simple. I'll go through the step-by-step of how I got this result. So what you need to do is actually create a few feeds. So these are the feeds that I created. I created 5 feeds. To create a feed, just select new feed. Then you can name it, for example, test feed. Create. So you have a feed called test feed. And you can repeat for how many feeds you need. I'll just create one for this demonstration. And once you create the feed, you go into your dashboard. You need to create a new dashboard. So you can create test bot, for example, and you'll create. So the one I have is called the Turtlebot IoT dashboard. For this demonstration, I created this test dashboard, and in this test dashboard, it's blank. So what we need to do next is create blocks. So to recreate the dashboard I have, click new block, and I have 4 toggle switches and 1 text. So to create a toggle block, just select the toggle block and then choose the feed that you created, which was test feed. Click next. And what I did was this will be test feed. Okay. So when it's on, I actually set a value of 1. And when it's off, I set a value of 0. Okay. And then I create a block. So this is one of the block. And to create a text one, you just choose text. I'll be using the test feed. And what I did is test text. And what did I do? Yeah. Then the rest I just leave it as it is and create block. So now you can rearrange it by editing the layout. So if you did follow this example, you can create 3 more toggle switches and you will have something similar to this. Alright, so that's setting up the Adafruit IoT platform. Next is the MicroPython code that I created using Tony IDE. So what I did was import all the libraries, and because I have a few LEDs connected to the microcontroller, I identified the pins 1, 0, 1, 2, 3, and 4. I've also created the declaration for the SSID and password. So you can see here that the SSID is your SSID and the password to the SSID. I also have the MQTT client ID. This is by default. And this is the link to the Adafruit.com platform. And to get the username and IO key, you just need to go to this yellow button, click it. So you have the username and active key. So just copy this here into this respective username and IO key, and that should be it. Next, I also have declared the feed IDs. So if you go back to the feeds, you can see that the yellow feed ID is called yellow LED. So as shown here, yellow LED, and then red LED, green LED, blue LED, and the white feed will be for the ROS data. This one I'll explain more in detail later. So I also included a simple connect to the Wi-Fi function. So when it's connecting, it will show that it's connecting to the network based on the SSID and password. And then you will also have a timer that if it doesn't connect, you will just show that it's not connected to the network. Please rerun the script and you exit the program. But if it's connected successfully, it will show connected to your SSID. So you can see here I'm connecting the Wi-Fi, and then this will be the MQTT client function. So it will just connect to the URL, username, and key that you have set. So I call this to connect to the client, and then it will just show if it's connected, and if not, it will just exit the program. Some issues that I faced were disconnections. So I actually have this reconnect timer. So whenever it disconnects from the MQTT client, it will try to reconnect. Next, I also declared the feed ID locations. So for the yellow feed, this is the format. You go to your feed, and it's based in your account, so your username and the toggle feed location. And this will be the main one. I have the main callback function where you'll subscribe to the Adafruit IoT platform. You'll collect the topic and message. So for every message received, there will be two values, 1 or 0. And then if it receives either a 1 or 0, you identify which topic. And if it receives a message of 1, you will turn on the LED for that specific topic. Similarly, if you receive a message of 0, you will turn off the LED for that specific topic. So coming back to the ROS data, so that will be the text block. So if the message received is the DB3 is moving, it will actually blink the white LED, and then it will check for any change of message. If there's no change, it will just be in a loop. If there's a change in the message, which is the DB3 has stopped, it will stop blinking the white LED. So I've set the main callback function, which is this chunk of code, and I'm also subscribed to all the feeds. So I would wait for any message and just repeat this process, and only exit if there's a keyboard interrupt. So for example, like a Control-C is pressed, you exit and disconnect. If there's an error, you will show that the MQTT had some error, and then try to reconnect. And lastly is if there's a unknown error that occurred, you will just say exception occurred and state what was the error, and then you exit the program. So now I'll demonstrate the code. Okay, so now I'll connect. So now I'll run the program, and you can see it's connecting to the network. Now it's connected to my SSID network, and it's connected to the MQTT server. So if I were to toggle the toggle switch, for example, the yellow, you should see that the yellow LED lights up. And what you see here is that the topic received is from the yellow LED, and the message is 1. So if I switch it off, you will receive a message 0, and the yellow LED is switched off. So I can do the same for red, green, and blue. So for these, they will just toggle the LEDs on and off. And for this text block, if I manually input TV tree is moving, you can see that the LED will start blinking. And if I change this to has stopped, you'll notice that the LED has stopped blinking. Okay, so that's the end of the first part. Now I'll be showing you the ROS setup. Okay, so for the part 2, which is the ROS setup, what I've done is actually created a few Python scripts to control the Turtlebot tree to move from starting point to the end goals A, B, C, D. So for the first folder here, which is a move to, I created 4 scripts, which is to move the Turtlebot tree to respective points A, B, C, and D. An example of point A will be shown here. What it's about is creating functions, which is to move forward and left. And these are the functions necessary for moving to point A. What it does is actually moves the Turtlebot tree forward by 57.5 cm. It makes a left turn, which is a 90-degree turn. And it also moves forward by 22 cm. So this is the process from the starting point to point A. Next would be creating 4 other scripts, which is to return from the respective points A, B, C, and D. What is that does is that once it's at its respective point, for example, point A, it also uses similar functions but additional move backward function. So from point A, you'll move back about 23.5 cm, and then you'll turn left to face back the starting point, and then you'll move about 56.5 cm. And once it's at the starting point, you'll make a left turn, but I repeat this function twice, so you'll make a 180 degrees turn. So these are the 2 scripts necessary for moving to point A and returning from point A. These scripts are repeated for point B, C, D, and returning from B, C, D. So now I'll demonstrate the Turtlebot tree moving from the starting point to the point A. Okay, so let me just split this. Two. Similarly, return from okay, so now I'll demonstrate the Turtlebot moving from starting point to point A. Okay, so now it's at point A. Now I will return it back from point A to the starting point. Okay, so now that the Turtlebot has moved to point A and it has also returned from point A, these scripts will can be repeated for point B, C, and D. That's basically the setup for part 2. Now I'll be moving on to part 3. Okay, so now for the third part, which is to combine the IoT setup and the ROS setup. I'll be showing you the code that I've used to combine both part 1 and part 2. So in this code, I've created one Python script which subscribes to the Adafruit.io IoT platform. So as you can see here, I've actually used the same username and IO key. And then I also created a ROS node is called the Adafruit_IO_ publisher. What it does is it publishes topics point A, B, C, and D. What I've also created is a AIO feed name, which is called ROS data. This feed is the Adafruit.io text feed. So this one will be responsible for receiving data from the Turtlebot tree. Next, I also create some declarations. Start position to be true. This is only applicable for the initial setup. So the Turtlebot tree will be at the start position. And I also put the end position as false because this will be necessary for other parts later. And the current position to none. So when you run this code, you actually just print this connected to Adafruit.io block, and then you'll proceed to run this while loop. So what it does is it receives data from the Adafruit.io feeds. So you got the yellow LED, the red LED, green LED, and blue LED. So this data will be published to the ROS publisher, which will be sent to the Turtlebot to understand and carry out some of the actions shown here. So if the Turtlebot receives a data of 1, it will be covered in this section. So if the start position is true, it receives a data value of 1. It will actually tell the user on the terminal that the Turtlebot tree is moving to point A, and it will also send a message to Adafruit.io platform that the Turtlebot tree is moving. So, for example, if the data A is equal to 1, we actually open the Python script which moves the Turtlebot tree to point A. Then you wait for the process to finish and sets the start position to false because that's no longer true. And then it will set the end position to true. So initially the current position was set to none. Now it's set to A. Then it will also send the message to Adafruit.io platform that the Turtlebot tree has stopped, and it will print on the terminal that the Turtlebot tree has arrived at point A. So it will also repeat the same for if data B is equal to 1, data C equal to 1, and data D equal to 1. Next is that if, for example, the end position now is true, you actually return the Turtlebot tree to the starting position. So if the data is equals to 0, you will actually tell the user on the terminal that the Turtlebot tree is returning from point A. And then you also send a message to the Adafruit.io platform that the Turtlebot tree is moving. So if the data A received is 0, you actually open the file return from point A, and you'll wait for that process to happen. Once it's done, the start position now is true because it is no longer at the end position, and the end position will be at false. Then the current position from A will be set back to none, and it will inform the user at the Adafruit.io platform that the Turtlebot tree has stopped moving. It will also print on the terminal that the Turtlebot tree has arrived at the starting position. So this process can be repeated for if data B, data C, and data D is equals to 0. Some other conditions, for example, if the Turtlebot tree is at the end, but it receives a data value of 1, which means it wants it to go to the end. Actually, it's not possible, so I would set it to do nothing and just print that the user command is an error. And likewise, if the Turtlebot tree is at start, but it receives a data value of 0, which wants it to go back to start, which is also not possible. So it will not do anything and just print that it is a user command error. So this while loop will repeat with a sleep of 1 second. And that's basically the script that will combine all the individual navigational scripts and connects to the Adafruit.io platform. So now I'll demonstrate what happens if I run this code. Okay, so now I will just demonstrate for point A first. Okay, so let me just connect the script and I'll refresh this. Okay, so now I'll just demonstrate the full process for part point A, and then I'll fast forward everything for B, C, and D. Now you can see that once I toggle it to go to point A, it shows that it's moving to point A, and now it also indicates that the Turtlebot tree is moving. And now that the Turtlebot tree has arrived at point A, it also indicated that the Turtlebot tree has stopped. Now I'll send it back to the starting position. I'll just toggle this back to off. So now it's returning from point A and indicated that the Turtlebot tree is moving. And as you can see, it also states that the Turtlebot tree has arrived at starting position and the Turtlebot tree has stopped. So this is how the process would go for any individual point. Now I'll just fast forward the video of the Turtlebot tree moving for points B, C, and D. Enjoy.